Alright guys, if you're watching a recording, know that we just lost 15 minutes of recording. I will post these notes in here. I'm not going to recap them though. Strongly recommend people show up to the lectures just for this purpose, but I know some of y'all are taking it online. So what we are doing is we're working on the two different kinds of for loops. There's the for value in range, and then there's the for value in list. To do a for value in range, you use the range statement. For value in range, and then you give it a range. This means start at 1 and go up to, but not including 11, so it'll count from 1 to 10. Or we could do the for value in list. Here we actually created our list beforehand. All the numbers. This list equals all the numbers between 1 and 10, and we just add them together like that. Why would this be preferred to defining our list ahead of time? For a short list, it doesn't matter, right? I mean, we only have 10 values here, but what if we were counting from 1 to 10,000? I wouldn't want to define a list that had 10,000 numbers, all the numbers between 1 and 10,000. Instead, I just want to use a range statement. So finding the maximum or finding the minimum. What you do is you loop through it, checking the value, and then if the value that is currently your max is smaller than the one you're looking at, larger, let's just write it. So let's make up a series of numbers. List is equal to, and just type in some numbers separated by commas. And now we're going to write a loop that will find the maximum. Why are we doing this? Isn't there a max function? Yeah, there is. If we wanted to, we could just do this. Print the max of the list, and it's going to give us exactly the same answer as what we're going to write. But we're computer scientists. We want to know how to do this. So what I'm going to do is I need a word to denote my max value, so I'm just going to call it max v. I can't use max, right, because that'd be a purple word there. So max v is equal to the first element of the list. And again, we're talking so much about lists here, and we haven't even hit them. So I'm thinking about just kind of scrolling past the rest of this page. But let's go ahead and do it. So for every value in the list, if max v is less than that value, colon, then max v is that value. You see that? So if our current maximum is less than the new one that we're looking at, that new one becomes our max. And then let's print it out. Print.
So that way it's going to go through each individual item, whichever one, it's going to compare each one to the next one, and then it's going to say the highest one each time.
Exactly. So the first time it's going to say the max is equal to that, but then as it loops it's going to say, okay, is 34 greater than that? No, it's not. Is 234 greater than that? No. Is 54654 greater than that? Yes, it is. So that becomes our new max. Right. And then it keeps checking all the way to the end. Doing the minimum would be about the same, except instead of checking to see if something is greater, you would check to see if it was less than. So you would say, if minimum is greater than value, then the minimum is equal to our new value. So here's how they do it on the smallest. Smallest is equal to none. Alright? They wrote theirs a little bit more complex than I did, but that's okay. For every value in this list, if the smallest is none, or that value is less than our smallest, then this becomes our new smallest. Alright, that looks a little too techy for me, but we could have done that. If we wanted to revise ours to look like theirs, I see why you would want to do that, actually. And I'll show you. let's change ours to look a little bit like that. So instead of max v is equal to L0, make it max v is equal to none. And then this if statement should be if max v equals none, or max v is less than the current value. Hopefully it'll do the same thing, or it blows up. None's capitalized. Alrighty. So I needed to capitalize the N and none there, and I needed to do it there.
Does that just mean that it has an inherent value and it's...
It has no value at all.
I mean, but it's instead of just putting in, like if you didn't have it capitalized, it blew it up. But because it's capitalized, it changes the color of it. It's saying basically that there's no value there.
Right. If it's colored, it means it's a keyword. It's built into the language. And so none would be a perfectly good variable name, like we could do, you know, like
Right.
that. We could use it ourselves. But here, it's got a very specific meaning.
It's kind of hard to tell on the text because it just said none.
Right.
It didn't have any kind of color
Right,
coding.
right. No color coding or anything. Right. Okay, so hopefully this will work. And why would we want to write it like that? Because what if this list was empty? What if I took all of those numbers out? What's going to be the max now? Not 0, because 0 is not even in the list. Okay, this one blew up. So I'm going to remove that one. It says the maximum value is none. There was no maximum value in the list because there was no list. So that's why they wrote it a little bit more complex than I did. I don't mind just making it equal to the first value of the list and assuming that I have data. So if I was going to do that, if I was going to go back to it, I would do that. Max v is equal to the first value of the list, and I would remove this max v equals none or business. I think that gets the concept of looping through it a little clearer. It's less cluttered that way. So our glossary. The accumulator, that's a variable used in a loop to add up all the numbers. I was calling it total. The total variable is my accumulator. The counter. It counts the number of times that something happens. I could have been our counter while I is less than 10. We know what decrement means. Decrease the value of that variable. We know what increment means. Increase that value by 1. To initialize, that's when you give it an initial value that will soon be updated. Total equals 0. I is equal to 0. We have initialized our counter equal to 0 and our total equal to 0, and then we're going to write a loop that makes counter go up larger so that we can add them to our total. An infinite loop. The terminating condition is never satisfied, or for which there is no terminating condition, like the while true. Any iteration is a repeated execution of a set of statements using either a function that calls itself or a loop. Well, we talked about a function that calls itself. That's recursion. And I don't think that this... No, I didn't think so. So this chapter of the online text is throwing something at us that it doesn't talk about before. It mentions it in the glossary. A function that calls itself is recursion. And recursion can be used to do very many of the same things that iterating through a loop can be used for. I believe last week we used recursion to calculate all the values between 1 and 10 or something like it, and we wrote it both ways, a recursive version and a non-recursive version. All right, let's see if any of these exercises would be amusing. Write a program which reads numbers until the user enters done. Once done is entered, print out the total, count, and average of the numbers. If the user enters anything other than a number, detect that mistake using try and except. Oh man, that'd just make a great homework assignment. But it's pretty similar to things we've already done already. So how are we going to do this? Write a program, it's going to read numbers, so we're going to have a while loop. And if they ever type in done, we're going to bail out of the loop. So loop until user types done. I'm going to make this a while true loop just so that I can get the input, check to see if it's none, and if it's none, break it. There are other ways we could do this. So while true, let's get our input from the user. Before we can even try to convert it to an int or float, we need to check to see if it's a string or not. But first, let's see if it's equal to done. If s is equal to done, then we're going to break. We're out of there. Else, we can try converting it to a number. But we don't want that conversion to fail. So we need to put that in a try except block. So try this. Number is equal to the float version of our input string. And if a problem occurs, we want to tell them that it wasn't a number. Print our string comp followed by the words is not a number. And if we get that error state, we just want to repeat. We want to go right back up to the top and do it again. So we're going to tack on a continue there. Why are we going to do that? Because the rest of this code is going to be doing something with these numbers. Right? We need to keep a sum tally of the numbers, I believe. And the count of them and the average. So we're going to need a couple of things. We're going to need an accumulator. And we're going to need a counter. So total is equal to 0, counter is equal to 0. And I didn't tell the user what to do, so we ought to print them a message letting them know that they need to type in some numbers. So above our while loop, I'm going to do print enter numbers, 1 per line, type done to stop. Now that you've seen that, I'm going to remove the words 1 per line just so that I can get how about 1 per line with a digit there? Or done to stop. All right, I'm just trying to get it to all fit on the screen. All right, so we have good data at this point. They didn't type done, and they didn't type any garbage that we couldn't convert. So what do we want to do? We have our two variables that we initialized, total and a counter. What should we do with counter? If it's just going to be a count of the times that they entered numbers. We're going to add 1 to the counter. It's going to increment by 1 each time. Counter equals counter plus 1 or counter plus equals 1. Then what do we want to do with the total? We need to update the total as well. We just don't want to add 1 to it though. What? Yeah, we want to add our input, and we calculated the floating point version of our input. What variable did we store that in? Yeah, so here, this guy's got our value from what they typed in. So let's add that on to our total. Total plus equals num. And this is kind of a parenthetical comment, and don't type this because I'm just going to erase it immediately. Why couldn't we do something cool like this? Num is equal to float input like that. Why would this not be appropriate for this particular case?
Because it doesn't check to see if that's proper data. It's going to blow up.
Right, there's two reasons why. One is that if they typed in garbage, it would blow up. Now we could fix that by putting it inside of try accept, but the other one is it doesn't give us a chance to check to see if it's done, if they typed in done. So we've been doing that as a shortcut on our code, but you won't always be able to get away with just doing a shortcut. Sometimes you need to check to see if your data is a value before you do something else with it. All right. Once they finally do bail out of the loop by typing done and the break is hit, we need to calculate our average. We have a counter and we have a total, so the average is easy to calculate, right? How do you get the average? Average is equal to what? Total divided by the counter. Now this is also going to blow up if they typed done before typing in any data, because counter will be 0. So we might want to put that in a try block itself. But for now, let's print out the counter. Count equals %d, total equals %d. No, wait, these could be f's, so let's do floating points. And the average is equal to %f. Followed by a %sign, and then followed inside some parentheses by the variables that we want to fill in our placeholders. That's our counter. This is going to be our total, and this is going to be our average. And you can type all that in on one line. I just didn't because I want it to all fit on the screen. Oh, I made a mistake earlier that I haven't corrected. If you run it and it starts talking about that max still, it's probably because you did the same thing I did, which is to remove all the values in the list.
So I ran it, and the first thing I typed was done.
Yeah.
It blew up because it caught division by 0.
Yep. So if you run this and you don't type any data, if you just give it done immediately, it's still going to blow up. It's going to try to do a divide by 0. So enter numbers 1 per line or type done to stop. So done. Nope, they didn't like that. Alrighty, let's do it again. Let's go ahead and give us some valid data. Neat. Let's type in some garbage. It says that's not a number. You fool. Try again. Alrighty. And then done. Looking at our loop here, if we didn't want to use a break statement, we'd still need an if statement in order to get this to not work. I mean, what? If we didn't want to use a break statement, we'd have to revise it. And I'm going to show you what the revision would look like, but I don't really want you to do it, if that makes sense. Here's what it would look like. So instead of, rather than if s is equal to done break, we'd want to do this. If s is not equal to done, do all of this goodies. And then we'd have to initialize s equal to something that was not equal to done up at the top. That's what our code would look like if we did away with the break statement. If you think that looks cooler, if you think you like the way that looks, feel free. You certainly do not have to use break statements. Oh, excuse me. If we did that, we would have to change this. While s is not equal to done. Like that. All right, that's the same code expressed, but without a break statement.
And the break looks better.
I like it better with a break, honestly.
Because you have basically S not equal to done twice. And
Exactly.
It's confusing.
Right. We're repeating our condition. We have our while based on the same expression that we have here. So I prefer doing just while true with a break. I think it's easier to read myself. And the majority of our code here was only one level deep. Well, this was kind of 2 levels deep because we had it in a try block. But here, you know, we have 3 levels deep in order to accommodate it. So, all right. Write another program that prompts for a list of numbers and at the end prints out the maximum and the minimum instead of the average. All right, so we're going to use this as a basis for a homework assignment. But we're going to monkey with the requirements a little bit. Oh, that didn't work. Oh, please be going still. Okay, good. Alrighty. So write a program which repeatedly reads numbers until the user enters done. Once done is printed, print out the total, count, average, maximum, and minimum of the numbers, as well as how many even numbers were entered. If the user enters anything other than a number, detect that mistake using try and accept and print an error message. And skip to the next number. So, what things are we tallying? We're having to tally count, total, average, max, minimum, and evens. And for this case, even is defined as if number modulus 2 is equal to 0. All right, so we've written the majority of this code already.
We did the max and the min, or like the max v earlier. We put those values into a list.
Right,
And
and
create a list. When we have them put the input, do we need to have that input go into a list?
right. Very good question. Since our code showed us using max and min in a list, do we need to put this data in a list? Yeah, we could. I'd rather you not, particularly because we haven't learned about lists yet. But yeah, well, we've seen it. The way you would do that is something like this. Max value is equal to. Now I see the point of them doing none. But max value is equal to none. You do your loop while true. You get your input. Input S, if S equals done, break. Else convert. And then you would do if max v is equal to none or max v is less than n. Max v is equal to n, like that.
Okay.
And so you wouldn't have to store it in a list.
Alright, so going by how you wrote it earlier, of just stepping through each value to see if it's
Right.
greater than the previous value. If it is, stored to that. If not, continue to the next place.
Exactly, right. So to do the maximum and the minimum correctly, you should follow the example shown in Chapter 5 online of using the none keyword like this. Obviously, this is not valid Python, right? All right. We all good there? I know y'all could do it right now, but don't. We're almost done with our time anyways. All right, was there anything else in this chapter that we wanted to look at? Next one, we will examine lists in more detail in a later chapter. Good. Lists are incredibly important. Lists and looping are it's what it's all about.